A couple of years ago, when the Talon was first released, I happily went out there and bought one, and I loved it. I loved it. So this is another version, but there's also this new polymer plastic frame that they got now as well that they're claiming is unbreakable. Go look at the website. It's a little bit kind of confusing how they got it laid out. Anyways, this is the V2, but it's the one that has kind of the cambered, if you will, the raised vertical arms here, rather than the first edition, it was flat. Okay. Now, looking at this, there's a couple things I want to mention because I made a mistake. I made a fairly big one, I guess you'd say, but you know, outside of time and a little bit of money, it wasn't that big of a deal. But looking at this first off, the frame construction of the Talon, I want to say, is excellent. If you're into the vertical arms and you like it, there are some complications with it, but there's also a lot of great benefit with it. If you like it, this construction is great. It's pretty rigid this way, the way they have it bonded into the aluminum structure in the center here, and then this way, flexing it this way, is very rigid. So it's good. And actually putting it together, when you open this up and you dump out the box of all the little parts and pieces everywhere, there's also these weird little pieces for mounting the motors there. It might seem a little daunting, but it's actually one of the easier frames that I have built. Now, having said that, what I did, I purchased all the elements like I would for a normal quad to put in here. And when I got them, there's a couple things that didn't fit. Now, one is a fairly large mistake, and the other one, you know, if anybody else did it, I could go, yeah, I could see how you did that. So here's the first major one. They made this new cage up here a lot smaller than the previous versions. So much so to where, here, I'll measure it for you, it's 20 millimeters or so right here, if you can see that. So much so that it will not even take a mini. This is a Foxier Mini, and it's not going to fit in there. These are, if you look at it, 22 millimeters. So it can only take a micro. So that's first mistake there. The next one had to do with this spacing right in here. And if you just want to see a number, check this out. So we get about 42-ish, maybe 43 millimeters from here to here. That in itself shouldn't be too much of a problem, because if you look here, here's the holes that they got. And they did kind of an interesting thing by making these slots. If you notice, they have a taper to them. This goes from a 3 to a 2, so you could put a 20 by 20 flight control board in here if you like, or you could put in the regular 30 by 30. But it is designed for that, you see. So for example, here is a typical 4-in-1 ESC, and it sits in here just nicely, right? I went and bought the Diatone Mamba, the F7 stack, and here is the 4-in-1 ESC. And notice what they've done. So if you just look on the website and you look for, yeah, I want a 30 by 30, I want a 20 by 20, or a 16 by 16, the whole pitch on here, you want to take a look at the rest of the picture of this, or they should include the dimensions of the board on the website somewhere in the specs, okay? So as you can see, this one isn't going to fit in here, and that was a bit of a bummer, because I used the Diatone Mamba 20 by 20 in the last micro, the 3-inch drone that I built, and I think it's pretty nice. But this one doesn't fit. So I wanted to show you that so that you know what's up. This build or any build, if you're just going on the fact that, hey, it's a 5-inch drone and it should take a 30 by 30, make sure you check however you can the dimensions of this and figure out possibly what the dimensions internally of this might be. So that's what it is. I now have, obviously, here's my micro camera, and I went with this guy. Who is this guy? So I went with Joshua Bardwell's stack that he has. So it's his F4 flight control board and his 4-in-1 ESC. So This one, according to the dimensions on the site, should fit, okay? So that's what I want to do first. I want to check this out, and I want to check the camera out. And if you're watching this, unless I'm into just showing off every single mistake I make, it must work, right? Otherwise you wouldn't be seeing this. So let's get this out of here. I did like the looks. I did like the looks of this, the layout of everything on that you could see from the site and his documentation. He did excellent documentation, as you would imagine that he would, right? He's got the manual that he wrote for this stuff, which the only other company that I've seen that has made even close to the comprehensive a manual was the Holybro Kahoot. Most of us, we get a little bit of like a one-pager or a wire diagram. So, oh, look at that. We got plenty of room, you see? So this is going to work out nicely. So the next thing I want to check then is make sure that I got the right camera. So let's get into here. That. And the only reason it would not work is if somebody somewhere lied about their dimensions. So this guy is going to happily fit right in here. Now they're doing the same thing here that they do on the 3 inches that I'm noticing, that they don't include a pivot pin, a pivot screw on here. So you're just going to screw this together with the one hole that you have here and just make it tight enough. Hopefully we even have a couple little washers in here, because now we're back to shimming things again. Make it tight enough to where it doesn't flop around, it holds still. And they usually work pretty fine. And if you do it right, it's tight enough, but loose enough that if you want to, you could just sort of grab it and bend it and change your direction if you don't like that in the field. Okay, so everything we got is going to work. So now we can get into the build. Let's see, I'll get started doing this. I'm going to put the pins in here and be right back, just get this set up. But again, I said this in the last Marmot video, I'm going to try to get away from all the soldering of all the components because I have so many of these drone videos, and if they're, by the way, on the site or not, trust me, I do. And they were all showing all these, you know, every single one, how to solder, how to solder, how to solder. Let's assume that you know how to do that. And if you don't know how to do that, go back to one of the earlier soldering and ESC videos, watch that, and then come back here, because it's all going to be pretty much the same until something dramatically changes. Just to go over it, power ground right here. I like these little, in different worlds we call this castellated, but I like these little notches that you put in here, because you can just put the big cable that you have in here. So trying to like solder it onto the pad, you can just sort of stuff it in here and put a blob over the top. That works pretty great. These ones across the way here, this is great. They're kind of tiny, so beware, and they got a hole through them, so a lot of times your solder is going to run through, but in most cases they are doing that so that they could bring it down, the conductivity down from the top, and anchor it to the bottom. So we actually have a nice little via going through there. But just know that if you heat it up too much and sit on it for too long, the solder is just, of course, going to run out underneath. Okay, so I will be back in a moment. I'm going to get this all done, wired in. And as you can notice, my wires are already pre-cut and kind of tinned because of the last board that was in here. And thankfully, it looks like everything's going to be fine. I was a little bit worried that maybe with the new board, something might be kind of short. I did want to show you this real fast before I go on my way. The pigtail, this is one of the pigtails that I buy already done. The Bardwell ESC does not come with one. It doesn't come with one of the ones you have to put together. So just know that you're going to need to have one of these, either buy or make one. The thing I did want to mention, though, is with the Talon and these underslung batteries. And what I mean, if you don't know what I mean, is the battery goes underneath, not on top like we do on some of the other drones, okay? So this is down here, and you could mount it sideways like this, or you could mount it like this, depending upon where you want the weight to be, okay? Now, if I'm going to connect this, if this is strapped underneath here, and I want to grab this and I want to connect it, You see, I've got quite a bit of excess right there. If I suck this up like this and just have it enough to where it can still bend right there, I could come along here and grab this and I could connect it. It might not be terribly too easy. Of course, it's going to be easier if I had two hands here, but what I don't want to have is this, and this is always kind of tough for people, especially new people putting these together, is you think excess is better, right? Because you can always cut it down. And that's cool if you don't mind desoldering these horrible pads over here, because they're just so big. And so what happens is you can connect it like this, and now you've got all this extra wire that has its ability to maybe get stuck or clipped with the propeller. Now the underslung battery, it's probably going to be a little bit difficult for this to get back up here, but things happen. So I would say if I made it this short, I would be good here. If it's still that short and I decided to run it like this, well then I'm still good as well. Okay, so let's measure this. What do we got here? So this is, I'm saying all total will include right up here by my thumb, you know, where you're going to cut this to the end of the connector there, 40 millimeters excess. So 40 millimeters. We'll cut it, we'll strip it, tin it, and then we'll put it onto the pad, and then we'll probably have, you know, a little less than that when we're done. Another thing you can do, by the way, with these castellated holes right here, ends, is if you want, you can kind of mount it like this, which could be pretty darn good with this, or you could even put it at an angle, because if I put it straight down, this might get kind of a little bit more or less whacked on the ground, so I can put it at some nice angle like that. So this is going to be a good deal. Matter of fact, I better put it the right direction, you see. I wanted to show you another slick little trick in case you don't have an abundance of other material around, specifically you know, spacers and such. So I have these longer fasteners, and I'm running them up underneath here. The 4-in-1 ESC didn't come with a whole lot of extra hardware. If you have it with the frame, that's cool. Like if you have it on the frame, I might use for a spacer for the ESC to keep it off of the frame. I'll prop it up with maybe a nut, or possibly, here you go, like one of these longer nuts. But if you don't have these in a pinch, you just clip this off, right? From this piece here, grab this. This is, again, this is the 12 gauge. I would make sure that you try your best to pull out a bunch of wire first, because if you cut them down first into little baby pieces, you're going to have just piles of little tiny wire all over your bench, and it's going to get on something and short something out. So take this, get rid of all that wire. Okay, it's actually been tinned on the end, so it shouldn't come loose, but take it, get it away from you, throw it away. Now look at this. So I can take this here, there's already one there if you didn't notice it already, but cut them down to whatever size you need. You probably should be pretty accurate with how you cut them, because ultimately the flight control board maybe, let's say, should be straight, but honestly you're going to calibrate it, so theoretically you should be able to put the damn board in here sideways and calibrate it out. But check this out, the 12 gauge wire is actually, the shielding is tight enough that this works really good, that you can pull this down onto it, and now it's going to hold that in place right there so it doesn't fall away, because you don't, you know, you're always trying to hold on to 15 fasteners at the same time you put the board on here. So I think, by the way, this is going to be okay. I haven't even tested this for length, but I've only got, I've got 2 stacks. I don't have any kind of a special camera or a stackable VTX on this, so I don't need 3 things. But I do need to clear this carbon stump right there. So that could definitely cause some problems with the ESC if it touches. Keep if you plan on building quads, first I say collect everything, start getting fasteners and whatever you need, but at the same time maybe keep some of the trimmings around a little bit. So you see there, that one's a little bit taller than the rest. If I wanted to, I could clip it down, or when I put the nut on the top, the fact that it's kind of squishable, I could just tighten it down until everything seems as level as I would like it to be. So then here, this guy, okay, there we go. So check that out. So that will give us absolutely enough clearance. All right, I kind of paused along the way here to show you something specifically about this board. A couple things. First off, the ESC pads are very small, and as I mentioned before, they have a hole in them, and you have to watch out that the solder doesn't leak down and through. They're also just so small that any blob of solder on the top is just going to ooze over anyways. So I wanted to show you this. These are definitely not the best solder joints I've ever done in my life. But then if I look underneath here, see if I can keep this in shot. Look right here. Can you see all this? All those little guys hanging down there, those are going to have to be obviously cleaned up. But it was really difficult to get the whole pad on the top to melt so that everything was homogeneous, as I say frequently, and not have it start to ooze down through the hole. So do your best and then maybe let it ooze, but then come by with a dry iron and clean that up after you're all done. So then here's the next thing, and this is almost even more concerning. You're trying to solder these pads on, of course, and maybe you don't want to use your tiny solder tip, but maybe you should change out to it, because I just finished doing the large pads there and I still have my big tip on here. What I want to point out is these very tiny resistors. So all through here you have all these 0402 resistors, and this is a very sharp tweezer tip, so kind of use that for a gauge. That is not, both of those right there, this regulator or something, again same thing down here, all very close to where you need to solder. And if you're using a large tip and you're kind of smashing it around here, you could easily touch that right there. Look, that's about as wide as my tweezers are. You could easily smear that off of there and not even realize that you did. So be very careful about that. Okay, it is all done, routed, zip tied up here, kind of strain relieved all over the place. Ready for our first test, which is just going to be a battery test at this point. So any of the builds, this is what we do. This is one of the first tests along the way to make sure we're good up until this point. So if you can see this, here we're going to go ahead and plug this in, and we're going to get half of the beep tones. Ready? Here we go. Well, that was pretty quick. Ready? Here we go. That's it. So seems good, sounds right. Theoretically, maybe one could be bad and I didn't notice it. I don't know if the beep codes would show that or not, but it beeps at this point in time. So our next step then is to find our flight control board and plug it in, and then we can do another beep. Before we even do anything else, we can check it to see if we get the full beeps. But just before we do that, we're going to check the flight control board to make sure that it's good in beta flight before we connect it. You see kind of the scheme here. What's going on is if there's a thing that can be tested before it gets connected or touching anything else, check it by itself so that you know if it's bad then, or if something comes up bad later, you know where it failed at. But before I show you that, I really want to go look at this again. Let me zoom in. Okay, I'm looking through the viewfinder as I try to point this out, so forgive me if I seem a little bit spazzy with the pointer. But I want to express again the closeness of these little tiny resistors right here and around the board. The ones here are really, really close to this. And if you struggle with soldering, oh God, look at that one right there. That one would be so easy to just touch that right there on the side and just smear it away. If you struggle with these, practice on something else before you do this, because you might get in here with a big solder tip and kind of be smearing around, focusing on this particular element right here, and end up wiping out that resistor. So I think that's a big damn deal there. Be careful. So I'm not real thrilled about that. I can see, you know, 1 out of 10 people probably killing that. Then here is the flight control board. So we'll get into that. So one thing I really like about this flight control board is that they did a really good job at labeling everything. So that's going to make it really nice for people that are new to this, and also the documentation is fabulous. So then we'll go over to the computer, we'll plug it in, we'll make sure that it wiggles around. That's really all we need to do, is just make sure that it turns on and functions at this point. Then we can come back, we can mount this in place, get the cable connected, we can plug our battery in and check our beep tones, and then after that works, then we can go back to the computer and we can even check our motors at this point to make sure that they spin as they're supposed to. And then after that, we'll get to soldering all the components on. So I'm over at my computer. Look up here at the top again, as usual, for the COM ports. This is a Linux computer, so the ports look kind of different, but trust me, it works. So I'm plugging in the board now, and you'll see the port change. There we go, ACM 0. Give it a second to kind of finish booting up. It seems like it took a little bit before. We'll connect. There we go. It seems to work fine. This is interesting here. So this is not pre-configured. So this is for our receiver. We're going to need to come here and tick one of these on for SBus so that it functions. And if you look here under configuration, we will probably see, well, that's interesting. We see a little bit of something. A lot of times you'll see nothing here if nothing's checked, but we'll have to sort that out later, okay? So that's it. It works. Let's go ahead and disconnect from here. We'll go back over to the bench and check our cable. Oh, I kind of jumped the gun a little bit. I need to put my little rubber bumpers in here. So let me get this done and then we'll test it out. Look at, what the, God damn it. What the hell? There is another little tiny capacitor, it looks like. Right freaking there, man. Keep the stuff away from the pads. Watch out for that. Probably don't need those. There we do. Those are the frickin' flippin' VTX. Oh, so it's a bypass cap that they have on most likely the power and the ground right there, but it's right next to, oh, here, I pause, gotta check this, I gotta test this. Oh, jeez. Okay. So I'm betting that a 5 volt will touch that side of the cap and the ground will touch this side. So let's give that a check. Okay. Right. So this is, okay, it's maybe not so horrible, but just don't kill that thing. So you're going to need these pads right here for your VTX. It's going to be the power for the video transmitter. And it could be pretty easy to wipe that thing out. But just know that if your solder blob sneaks up and wraps around the side of this capacitor, this device right here, it's okay. It's actually connected to that. Okay, that was a little bit tougher than most. Look right here, there's our arrow. We're going to make this be the front. This is the back, so it's going to sit here like so. Okay, so that's going to sit down, and then look, we've got miles of room on our little made-up spacers right there. So you see, that's not so bad. Man, I got lots of room. So it's nice to know it's easy enough that I can just take those and clip them down a little bit, which you're going to have to do. I'm going to have to do because I don't have enough room for the nut. Okay, but anyways, let's check the cable first. Let's just make sure that that is working. So here is it. let's assume stuff. Let's assume that it's wired correctly for their board, and I don't need to do anything. So plug this in, flip that around. Okay, and of course we're going to bury this later. So that's it. Let's zoom out. Good. So now we will plug the battery in. We will hopefully get all of our beep patterns, and we'll see our typical lights on the flight control board. Here we go. There we be. Do it again. Excellent. Okay, so that's a good portion of things done. Gosh, I do need to get the camera set up over at the other bench so I can plug in the camera and show you the motor spin, because I think that's just a thing we have to do every time. Okay, so I will go get some stuff sorted out. I'm going to cut these spacers down so it fits a little bit better. I'm going to bury the cables like I said that I would, and be back in a minute. So here is what I'm going to do. I don't want to set up all the crap over on the other bench, so I've just got a really long extension added to this. So I'm going to plug in the board, go over to Betaflight. Well, of course, I'm going to put a battery in here as well, and we're going to spin up the motors. That's basically it for right now. I do want to mention a couple things that I've done. I cut down my spacers a little bit, you know, the little silicone trick, and got it to be what I would say is just right. Everything seems to be nice and squishy. That's kind of an added bonus of having all silicone spacers. You got this kind of nice little bit of cushion all over the place. Now, when you tighten it down though, the little shock pad mounts in here, you're going to kind of squish the snot out of these a little bit. It might be in your best interest to put a washer on there if you got the space to do that, right? We're kind of limited of sorts. The other trick is once you get this thing tightened down, hold this like this and spin the fastener. Don't twist this, because then you end up smearing, you know, that around a little bit more than you need to. I also opted for, out of my kit, the Nylock nuts, because I like those, and so I tighten it up just to where you could feel it cut into the nylon that's inside of those, so I know that these are not going to go flying off. That's my own personal choice. The other thing though, let's see, hold on to that cable. Oh geez. When you're stuffing these wires underneath here, there is it's a little bummer that this connector is right over the top of the other one, because that's our space, that's our gap right there that we need to have for these two for the two connectors right here. So that's what I had to do. I ended up cutting them down, and I went too short, and so then I had to make a couple more just to get it to where there's still a little bit of a gap between there. I'm not pressing on the connector. But the thing I wanted to show you though is when you just go ahead and stuff all your wires on the inside, make certain that none of your wires are trapped between these connectors, because it's smashed down enough here that it'll be contacting and squishing that wire a little bit, and as you fly your quad, it's going to shimmy around, and I feel like eventually it's going to cut through that wire, and then you're going to have some problems, right? So make sure you tuck them one way or the other. Okay, so we'll go ahead and plug this in, and then we'll throw a battery on here as well. Kind of running out of space. Okay, and then I'm going to slide on over to the other computer if I don't kill everything along the way. Go here, and we'll go to our motors. We want to check two things on these. Every time we have a board to board interconnect, the wire that goes from one board to the other, or a set of pins that connects between the boards, I want to make sure that the pinout is correct. And I could have just read the documentation for sure, but all I'm saying is I'm going to come here and we're going to spin the motors up. Now, all the time I do this, I click right here, and then I use the arrow keys on the keyboard to slowly bring it up. There they go. I was a little bit worried, but they're starting to twitch. One more click. Watch the numbers on the 1, 2, 3 motors there so you can see when I'm clicking if you can't hear me hitting the keyboard. 1038, 1039, 1040, 41. Okay, now they're spinning. I had to bring them up quite a bit to get them to go, you see? But I'm pretty sure I know why that is, and I'll show you in just a second. So I will bring these down, and then what I want to say is watch motor 1, so the bottom right corner. So I'm going to turn on motor number 1, and that one goes. And then 2, every single time I do this. There's 2 up there, then 3. Oh, that's nice. 4. Okay, so we know now that our wiring order was correct. The reason I say this, if you don't watch every single video that I make, we did a little bit ago an Armaton Marmot with CL Racing Flight Control Board and CL Racing 4-in-1 ESC. And even with the same company, the motor order was backwards and we had to swap them around. So here is what I suspect is going on with the motors. You see right here. I suspect this because it's usually this way. Sometimes it's on D-Shot 600, but given the fact that they didn't set the ports up here, kind of figured that they didn't set the ESC protocol as well. So we're going to go D-Shot 1200, reboot the sucker, come back, and I suspect that we'll start to get some reaction out of the motors with just a little bit of throttle on here now. Okay, we're back in. We'll go back to motors. Oh, first go to configuration, make sure that it's stuck, because if it can't support it, whatever it is, sometimes it's ports and sometimes it's things like smart port and smart audio. If it's wrong or it doesn't take it, you come back and it will just be gone, right? So it worked. D-Shot 1200. We'll go to motors. So I set my lapel mic over there and I can talk over on the other mic if everything doesn't echo too much. So I come over here now. And now I can bring the motors up. Tap, tap. About 1001 they do something. And they kind of start moving around 1018, 1020 or so. Man, those sound nice. So that is our ESC in and verified. That is our flight control board plugged into USB, verified. Then our flight control board connected to our ESC and checked for beep tones, passed that. And then plugged it into Betaflight and tested our motors, and all is good so far. So I'll go ahead and leave this one right here for now. And then the next video, we're going to go ahead and just knock out all the rest of the peripheral components. We'll go ahead and install the camera into the top cage. We'll solder on all the wires because it's really not that hard, especially when it's so clearly labeled on here. So we've got camera, we've got receiver, and we've got VTX, and then we're basically done.